Welcome to video number 3. This one's called Foundations of Adding and Subtracting Integers. Remember that any keywords and vocab words that we have are going to be in red. So our next word is algorithm. Definitions are in blue. A plan or series of steps for doing a computation. So think about what that means for math. Plan or series of steps. Here's an example that you know a lot about though. How do you make a peanut butter and jelly sandwich? Well, think about the plan or series of steps that you have to go through to make a PB&J. You've got to put the jelly on the bread, peanut butter on the bread, and then put them together. So think about what that means for math. We're going to talk about a plan or series of steps for doing a math problem as well. We've also got several properties. Remember, properties in math are kind of like rules. They give us reasons why we can do certain things. So one of those properties is called the commutative property of addition. It tells us that the order of the addition of two numbers does not change the result, or the sum. So think about what that means for an example that we know about. So like 2 plus 3 is 5, and 3 plus 2 is 5. So think about the property of commutative property. It comes from the word commute. Think about when you're going to school in the morning. Maybe you ride the bus. So when you ride the bus, let's say that you and your friend sit in a seat together. Well, it doesn't matter if maybe you switch places. If you're on the right or on the left or vice versa, you're still going to make it to school. The result does not change. Think about what it means for variables too. Sometimes you can take away the numbers and put in variables or letters, and it means the same thing. A plus B, which means any number A, any number B equals C. If we change the order, B plus A also equals C. Here's another property. Remember, properties are kind of like rules. They let us do things in math. This one is the associative property. Like commutative property reminds us of commuting to school, going back and forth. Associative property reminds us of associating. Think about associating with certain groups of people. So think about these parentheses here. 2 plus 3 in parentheses plus 5 equals 10. What if I took the parentheses instead and put them here around the 3 plus 5? 2 plus 3 plus 5 in parentheses also equals 10. So the associative property of addition allows you to change the groupings of the add-ins. So think about with your friends. Maybe sometimes you'll hang out with this group of friends and sometimes you'll hang out with this group of friends, but the result is still the same. Same thing with letters. A plus B as a group plus C is equal to D, and A plus B plus C as a group is equal to D. If we change the groupings, the result does not change. Another key word is absolute value. Absolute value is the distance from 0 on a number line. There's a certain notation that we also use. You're going to see straight up and down bars. They're not parentheses or brackets. They are straight lines. So this means the absolute value of -2, or how far away it is from 0. Well, look at this number line. If I'm going from 0 to -2, I have to take 2 hops. Doesn't matter which direction I'm going, it's the distance from the 0. So the absolute value of -2 is 2. Absolute value of +2 is also 2. So it's the distance. How many hops I have to go from 0 to that number. So notice absolute value of -2 is the same as the absolute value of +2. We're going to be doing some work with fractions, so remember that you've got to be able to add them well. So here's a review for you. Remember that if you have a problem like 2 1/3 plus 1 5/12, you must find a common denominator. So here you can see that I've changed the 2 1/3 to 2 4/12. The 3 became 12 and the 1 became 4. If I do 3 times 4, I've got to do it on top as well. Remember, when you're adding fractions together, the denominator stays the same. That's the most common mistake. I added my whole numbers first. 2 plus 1 is 3. My numerators, 4 plus 5 is 9. and my denominator stayed the same as 12. Always reduce, so my final answer is 3 3/4.